Hypothesis testing for a population mean. I keep referring to this as 10.3. Just ignore that. That's from a different book. We are talking about hypothesis testing for a population mean. Enjoy the videos. Okay, folks, we're going to be talking about 10.3, hypothesis testing for a population mean. So hopefully 10.2 made sense. 10.3 is very analogous. So the game is going to be completely the same, except we're just going to have a new test statistic, which will not be Z like our standard normal table. It'll be T, the T table that we saw when we were doing confidence intervals for population means. Okay, so notice that the null hypothesis in 10.2 was all about P equaling some number. So in 10.3, we're all about the mean, mu equaling some number. Okay, so the game is going to be completely analogous. If p-val less than alpha, we're going to reject HO. So the game is the same. So hopefully 10.2 made perfect sense. So let's do that first problem on our worksheet. So the worksheet says, the newspaper says the average rent for a one-bedroom apartment is $1,300. You think it's more. You simple random sample 16 apartments. Okay, so if n is 16, remember with t, degrees of freedom is 1 less. So our degrees of freedom, I'm just writing things down, would be 15. Okay. You simple random sample 16 apartments and get a mean rent of 1,365. So based upon your sample of 16, you get a mean rent. So that's a sample mean. So our x bar is equal to 1,365. Oh, I guess I should mention, I'm going to do this first problem. Remember when I explained 10.2, I did it the long way using formulas. I did the critical values, and then I said, okay, that was all fun. Let's do it really quickly using our calculator. So same game plan. Buckle up. Okay. Sample standard deviation, that's S of 180. Assume the rents are normally distributed. I throw that in there because that's one of the minimum requirements. Is there sufficient evidence at the 5% significance level, okay, alpha 0.05, to indicate that the mean rent is more than 1,300? Okay, so maybe, let's see, so this section is all about mu. Maybe pause right now and see if you can write down the null and alternative. Okay, or don't pause. So they're claiming the mean is 1,300, and we think that the mean is more than 1,300. Okay, we just got the null and alternative hypothesis right. See how this is very similar to what we have been doing. Test statistic. So we have a new test statistic. See, it's this one right here. X bar minus mu naught S over root n. So let me write that down. T equals X bar minus mu naught, the mu mentioned in the H naught, all over S over root n. So that's going to be, X bar we said was 1,365 minus mu naught, the mu mentioned in the H naught, 1,300, over S. Sample standard deviation, they straight up told us, was 180, divided by the square root of, simple random sample 16. So put 16 here. Common mistake is you accidentally put the degrees of freedom. So the degrees of freedom we need for our T table, but right now n is just 16. Okay, now we need to crunch that mess. Maybe put the bottom in parentheses, top in parentheses so we don't mess it up. So when I go to my calculator, let's see if we can see that. A little more light. Is that helping things? Okay, so I usually do it in steps. I would go 1,365 minus 1,300, enter, divided by, so now the denominator, parenthesis, 180, divided by the square root of 16, slide out from the square root, put another parenthesis, enter, and we get a T equal to 1.444 repeating. Okay, so that is our test statistic. That's our test statistic. Okay, so now, let's get the critical values later. So we still need to do that. Let me put a little star here. Let's just keep doing this the p-value way, and then I'll show you the classical way. So the p-value way, maybe that was unnecessary. Well, let's just see if we can do it using our shortcut of a calculator. Let's hit clear. So over here, I should probably plan things out before I record them. Anywho, so the shortcut analogous to 10.2 is that we're going to use t-test. So let's go to t-test on our calculator. So go to stat, go to tests. T-test is that second one. Hit enter. And then they ask you the familiar question, is it raw data or is it stats, summary statistics? So they gave us summary statistics. Raw data would be a list of numbers. So let's go to summary statistics. Enter. The mu naught. What's the mu mentioned in the H naught? It was 1300. 1300. Okay, enter. What was the X bar? The X bar we said was 1365. 1365. Enter. What was S sub X? What was the standard deviation S? They straight up told us it was 180. 180. Enter. Sample size N. 16. 16. Enter. Oh, now they need to know what symbol goes in the alternative. Greater than symbol. Okay, so we slide over and choose the greater than symbol. Enter. Slide down to calculate. Hit enter. Ooh, check out that T. 1.444. Booyah. Okay, the p-value is, it says it right below the t, it says 0.08458. So I'll just round it to 4 places, 0.0846. Okay, so that's my p-value. And so the statistical conclusion, remember they said, I believe the significance level they said was 5%. Yes. So the significance level is the alpha 0.05. How does 0.0846 compare to your 0.05? This should be familiar. This is what we are doing for that test number 2. Our p-val is greater than our alpha. 0.0846 is greater than 0.05. So therefore, we would fail to reject HO, or our book says do not reject HO. Do not reject HO as our statistical conclusion. Okay. And then the conclusion in plain English. So if I say do not reject HO, then I say not enough evidence to suggest. Not enough evidence to suggest. And then we have to put the HA into words, that the mean is greater than 1300. Suggest the mean what? The mean rent. The mean rent where? What city? In Santa Monica. The mean rent in Santa Monica. Was it for a 1-bedroom? What was it? For a 1-bedroom, abbreviation, is greater than 1300. Dollars. Dollar symbol. R. Okay, so hopefully you see just how similar this is to what we were doing when we were doing hypothesis tests with proportions. So we still need to do our critical values. Let's go back to, I'll save a piece of paper over here. So the critical values, let's see. So notice that the HA is pointing to the right and that the alpha is 0.05 and that the degrees of freedom is 15. So if you go to your t-table, I'm going to put a picture up in 1 second, but if you go to your t-table, this will be blurry. I'll just go straight to the picture, but you'll notice up top, there's confidence level and there's area in one tail, area in two tails. You see how this is one tail? Remember, two tails is the does not equal symbol, so area in one tail should be 0.05, and that's pointing to the right side, so we're just going to go with the positive numbers. You'll notice that our z-table is nothing but positive numbers because it's a right tail test. You'll see on problem number 3, no, the next problem number 2, make sure you watch when I find the critical values for problem number 2, you'll see that we just make things negative. Okay, so I'm going to go to my t-table. I'm going to insert a picture right now. And you'll see that, go to DF15, go to area in one tail, 05, and you should see the number 1.753. So if I draw a picture of it, remember, the T doesn't exactly look like a bell curve. It's as if you get a bell curve and you squish it down. Okay, so it's squished down, and we should see the number 1.753, and it's on the right side. So if I shade this, 1.753, and remember that we called that shaded region we call the rejection region, just like we used to before, the rejection region, and we're wondering if we land inside that rejection region. So we have a test statistic of 1.44. Where does 1.44 land? Remember, the center is 0. That's 1.753. So like right around here somewhere is the 1.444, our test statistic. Do we land in the rejection region? No. Therefore, we do not reject HO. Aha. So I can use critical values to get to my statistical conclusion, or I could use the p-value method to get to my statistical conclusion. So when you're doing the homework, what you're going to notice is the book keeps asking you, hey, what's the critical value? And then you would just say, oh, 1.753. Okay. Hopefully that made sense, folks.